The third type of linear mixed effects model that we are going to discuss actually is part of a very big class of model which are called hierarchical linear mixed models, or HLMM, or multi-level models. Now let me illustrate this with an example. We have already seen examples of this type where we are studying the effect of technology, teaching technology, on performance of students. So the teaching technology could be whether I am using just a board, or I am using, say, PowerPoint, or I am using a smart classroom, etc., or I am teaching using some online mode. So these are the different teaching technologies. This is a factor. Those are the levels. And the students, and I've seen the result. Now naturally, school will also play an important role. So I have such a model. And suppose I am interested in those particular schools. So it is not that I have just picked up some random school. So I am interested in the schools. So in that case, I will have a fixed effects model like this: mu plus alpha I plus beta j plus epsilon I j k. Suppose I am considering these as I and these as j. So I of course have the random input. Now let us understand this particular input, school. Now when I say the school has an influence, so this beta j is the influence of the school. Now the school is actually consisting of lots of different things. For example, what is the average income of the parents there? What is the total area? Whether the school is situated in an urban region or a rural region? What is the amount of open space in the school? All those things are part of the school. So it is quite natural that you also collect data on those things, and you have something like this. You have school, and you have inputs like area, and we can have, so it is the play area. Suppose I say play area proportion. And we may have input like medium. What is the medium of instruction? We may have things like, say, the economic status of the average economic status of the parents of the students. And all these things gives you the sum total effect which comes here. So it is quite natural to extend it in this way. In fact, when you will collect the data, you will actually collect it in that way. So you will have a table for students. So student 1, student 2, etc. up to student n, and you have got their, so what technology they have been used and the results, etc. So you will have a student table, and then you will have a different table which is for schools. School 1, school 2, school 3, and for each school you will have various descriptions. That is why it is called a multi-level model. In the lowest level you have students, it is nested inside school, and like that. If you consider it like this, then isn't this box basically similar to this box? Here the output is somewhat abstract. Output is this beta j. So this beta coefficient is the output. Unlike here where result is a very concrete object, but beta is just a similarly measurable quantity. Beta is the effect of a school on the result of its students. Quite abstract sounding thing, but it's a quantity. And that is the output of play area proportion, medium, economic status, blah, blah, blah. Now, do you expect that all these things completely determine beta? So you can have a precise mathematical function describing beta? Of course not. The reason why we had a random error input was because I cannot model this exactly mathematically in terms of the inputs. The same thing works here also. So we must have a random error here also. So you see the beta that I have is actually result of certain things that are known plus certain thing that is random. So this beta must be considered to be a random quantity. So this will be basically Bj. However, in this case, I am not going to put a condition like Bj normal 0 blah blah. Instead, I will have the second level of equation. Bj is equal to, again, I will have another linear model which describes this in terms of these inputs, and it will have its own epsilon, it will have its own eta JSA. So this is the random error there. And the thing can go on and on. The school is situated in a city, so you will have some database for that cities. In this way, you have a multi-level model and you get various random effects because they are the result of the earlier levels or the higher levels. These are percolating down to the lowest level. And everything that comes through the higher level also is influenced by the random errors in those levels. As a result, they are actually all random. Now, if you want to write it in this way, R makes it particularly easy to do that. So in this case, what you will do is you have school and you have student. So you will write things like, so you have take here. So I have student and I have school. So that is one random effect. So you will write down all the models in the random part. So in this particular example, I have only one level. So I will just write one thing. Random list school equal to, then you will write tilde and whatever stuff you have for this input. If there is something else, then you will list that also. Suppose this is nested inside city. So before school, you will write city equal to tilde blah blah. Under that, school equal to tilde blah blah. And such a data set is called a multi-level data set. Typically, it will be stored in a database as different tables. But when you run R on that, you have to combine everything to produce one big table, which means student. Then for that school, all the information of that school will be repeated. And like that, finally, you will run a model like this, which will tell that city is the highest level, school is the next highest level, and finally the student, that is the lowermost level. Now, in our course, we shall not go into any greater details about these things because this will take us far afield. But I just wanted you to have a basic idea about how multi-level models work. If you want to read more about it, in that case, it's a good idea to read that book by Pinheiro and Bates, especially the section on split plot design, which is one very common example of multi-level modeling, split plot design. In the next semester, you are going to learn about split plot design, and many students have great problem understanding what this is and they end up cramming it. So I would suggest that before that class or when you are suffering in that class, you have no clue where to read split plot design from. Remember that this is a very good reference for learning about split plot design.